Welcome to AI for Good, the leading action-oriented global and inclusive United Nations platform on AI. Organized by ITU in partnership with 40 UN sister organizations and co-convened with Switzerland. The goal of AI for Good is to identify practical applications of AI to advance the United Nations Sustainable Development Goals and scale those solutions for global impact. In today's session, we're counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end, as we will hold a 30-minute networking session in the neural network. Here you can meet, ask questions to our distinguished speakers, connect, and chat with the AI for Good community. It is now time to kick off the session and welcome our first speaker. The floor is yours.
Thank you, Anna. Hello, everyone. Good morning, good afternoon, good evening from me as well. I'm Guilherme Martinez Roura from the International Telecommunication Union, and I would like to welcome you all for joining today's AI for Good webinar on Towards the Future of the Energy Industry with Intelligent Robots, organized by the ITU. This session is part of the AI for Good programming track, where we discuss the role of AI-powered robots in achieving the United Nations Sustainable Development Goals. We have a distinguished set of panelists today, but as always, we are counting on you, the participants, to help create a very interactive session. Without further ado, I would like to introduce our moderator today. Her name is Carol Nachle, and she's the founder and CEO of Crystal Energy. Carol, welcome, and the show is all yours.
Thank you very much, Guillaume. Hello, everyone, and thank you for joining us today to discuss the future of the energy industry with intelligent robots. And the first thing in my reaction was, I'm not aware of robots being unintelligent, but here we are going to look into the real transformation the energy industry is enjoying and can enjoy even more from the development in technology, particularly robotic technology. Now, unlike many of you, I am an energy economist by background, and maybe you would wonder why we would need an economist to be among us to discuss technical issues. Well, simply because of several things, I would say. First of all, the SDGs, the United Nations SDGs goals, when you read them, when you go through the details, you can see that they are interrelated. So there's no clear boundary between one objective to the other. And on the contrary, you cannot achieve most of those objectives if you fail on one. So there is this comprehensive approach. But most importantly, from what I have learned dealing with technology side of the industry, I learned that with artificial intelligence, with digitalization, with robotics, the boundaries between these different specializations have kind of disappeared. And they, of course, are still there, but you need to be exposed to all these kind of developments to have a good understanding of the future of the industry, which is undertaking massive changes. Back in 2018 at Crystal Energy, we did a report for Newsweek. It was published in a special report on the outlook of technology in the industry. And of course, artificial intelligence, digitalization, robotic technologies, they featured quite strongly. But I'll never forget when I had one of the people I interviewed for the report, who was a technology leader in the industry. And back then he told me, Carol, we know that the future is bright for digitalization, for robotics, for artificial intelligence, and all these related technologies. But we cannot really know how far that technology will go in the next 5 years. But we know for sure it's going to exceed our expectations. And that got stuck in my head. And that's why I got very excited when I received the invitation to moderate this panel. I'm really excited to learn a lot about the various developments that we are seeing across intelligent robots and how do they contribute to the sustainability of the energy industry, which is at the heart of the UN Sustainability Development Goals. With that, let me introduce our panelists. Each one of them is a true expert in his and her area of expertise. And they will be given, each one of them, 10 minutes to give us their views on the subject. Then we'll move on to Q&A. And I would love to get as many questions as possible from you. So please don't be shy and just send us your questions. I will not go through the bios. You have very rich bios available for you, but let me introduce them and then give them the floor one by one. We have Mr. Barry Mulder, he's the manager for robotics at Shell. Mr. Peter Funkhouser, CEO and co-founder at Anybotics. Ms. Katie O'Leary, Director of Product Marketing at Drone Deploy, and Dr. Ivan Petillo, full professor of robotics and computer vision at Heriot-Watt University, not far from me. I welcome you all. I'm going to turn first to Barry to share with us his views on the future of robotics in the industry. Barry, the floor is yours. Do we have Barry?
Yes, we have.
There you
somewhere. Go. It's underneath all those buttons. Excellent. Thanks, Carol. While I get my screen up. Here we go. For a nice background. Excellent. Can you see the screen? Just testing. Cool. Hi all, I'm Barry Mulder. I'm currently the principal technical expert for the robotics program in Shell, in which we try to figure out as Shell on how robotics can help us in the future for all the activities that we have. As we call robotics, it's our mobile automation or motion automation technology that really sort of brings that new dimension of how robots can really get us into the future. First, a mandatory thing on my slide pack is this part. Let me work. Yeah, is the legal disclaimer. I'll let you read it in your own time. Basically says whatever I say, don't buy or sell your shares on Shell, because I am going to talk about the future expectations. Just for the legal coverage. First. The purpose of robotics for us is, as mentioned many times, it's about the dirty, dull, and dangerous activities that we have in industry or in general. That's where robots come in. Also want to sort of put a new dimension on it. It's not for those per se, because if it would be really dangerous, we wouldn't do the job anyhow. What we actually do see robotics come into is help the people in their current activities because they bring a new dimension. Like for this person walking around this facility, we really find out why do we still have this person walking around today? Because there's nothing stopping us from fully automating this facility, putting cameras in there everywhere. Well, basically because, well, this person adds something that we cannot capture with 1,000 cameras, and that's that element of mobility. By walking around, a person with all his experience in this case can sort of get insights that is very hard to find so far with plain instruments and plain cameras. So we're trying to sort of develop that capability now with robotics, capturing that mobility element, but also with the AI on the background, sort of getting the insights that are, well, so far in the last 100+ years captured by people and gained in their experience. On top of sort of replicating what people do, some robots really give us literally new perspectives. By flying around, by swimming around, by walking around, we get new insights in our facilities in different frequencies or different trend watching kind of things that we didn't have. So it also enables us to do the things differently than we have been doing in the past. It's also not new because we have been using robotics for many decades. Actually, we claim that some of the industry's big successes are enabled by robotics, like the deep water production of oil and gas is only possible because robotics started to exist in the sense of ROVs, because no person ever goes 3 kilometers underwater to paint or open a valve or whatever. So the robots are there, but they now get to the level of, well, the facility you just seen on the pictures, walking around. That's that empowerment that robotics really gives us to do the same things, but then differently, because the technology becomes available, because the AI in the background becomes available. So we set ourselves about 3 sort of major goals in the robotics program. First, the good things that they should bring is better emission detection. More about that later. Of course, it's about safer work, because exposing robots is a completely different story than exposing people. And the third one is actually global collaboration. Robots are online per definition. And how can we use that capability to make people around the planet work together? One step at a time. Emission detection and operational surveillance, or asset integrity monitoring, as we also call it, is something where robots really come in. So back to the picture of that person walking around. What does that person do? Well, he sees, he hears, he may smell something, he sometimes touches equipment. So he's basically our data collection platform. But as a person, he also has that experience in his head to judge instantly whether a situation is good or not. With robots and in sort of the AI in the background, we're trying to replicate that process. With the big advantage is that once an algorithm has learned that it's instantly available for all the assets and all the robots out there, where that person that we just saw still has to share his learnings with all his colleagues in the field across the planet. So there's a lot that we sort of try to replicate today. So we have our robots flying and driving and swimming around in some of our assets, learning on how to build that capability. So in this example of an asset here in the Netherlands, we already get sort of like emission detection maps. And this is not about the big leaks. This is about the emissions, the ones that that wouldn't pose a big sort of explosive or fire kind of risk or toxicity, but mainly sort of the sweat kind of leaks. And with having robots flying and driving around, swimming around, we now catch them. So these are the really, you see on the chart some big peaks, but they're really, really, really small leaks. But we do want to catch them because we all want to improve on our emission detection and controls. So those kind of capabilities are basic. Having more emission detection going around on a more frequent basis to catch the leaks smaller so we can fix them smaller. But the good thing while going around is you actually get to see more of the assets. So having a camera on the robot allows you to take pictures of all the equipment and trend them. So it's not just about reading gauges or counting fire extinguishers. It's also about taking pictures of your civil structures, your mechanical structures. And if you collect those pictures 3 times a day, you have 1,000 pictures per year. That means you can actually watch the trends. If all of a sudden there's a brownish kind of crack in a concrete column, you know there's something happening with the column, and you can sort of you should take the action before something happens. Because in the end, everything that is happening, all our facilities are outdoors, so Mother Nature is really hammering on them every day. Basically, all of those things that work on our assets will eventually end up in a leak. So the earlier we see them, we detect them with AI, we can work on them, we can fix them. That's one of our major themes here. Second one, of course, is about safer work. Working at height, working inside confined spaces is something that robots are really good at. So we can eliminate that by having more and more robots running in our facilities. Simple examples like paint stripping, painting, but also if you really start to add sort of the power of digitalization and further automation of these robots is where currently some of those tools are really, as we call them, a tool for a task. So you saw this, the scraping robot just before. If we start to digitalize that further, one person can supervise multiple robots, or in the future, these robots actually start working together. So one drone may, for instance, detect some corrosion, and then another robot comes up to, well, try to sort of like, well, instantly catch the corrosion by spraying some paint over it. That's the power that we're really sort of after, combining robotics with digitalization, with the whole AI that comes with it. Last example I want to touch upon is robots are online, so global collaboration. Because robotics for us is a digital tool, so they are connected. There is a screen attached to it. And while in some cases, you still need a person local on the ground, if only for sort of attaching the robot to the tank, it's also, or flying a drone if that's mandatory by regulations. They are digital tools, so they can be connected to someone remotely. That really opens up a world of global collaboration where an expert can be sitting remotely, no need for that person to get on a plane anymore, and really spread that expertise across all kinds of sort of local operations. Some of those systems are actually already online fully. We have a whole fleet of robots that I can control from my laptop here while they're on the other side of the planet. That really allows us to sort of get global teams running that look after each other's facilities, after each other's health, after each other's integrity, and really enables that next level of global collaboration. This is in short what I wanted to sort of pitch on where we are as Shell, getting all those elements out there, learning by doing, consciously saying this is not perfect yet, but we're learning by doing with all the right intents. So it is about bringing emission detection to the next level, It is definitely about safer work and using the global collaboration, using the global or the features of robots that are online per definition. Carol, this is where I wanted to leave it for now.
Thank you very much, Bariam. This is quite impressive because I feel that many people still think of the oil industry as still getting oil and gas in the dirty way of 2 centuries ago. But it's fascinating, the advances in technology that we have seen in the industry, and there's much more to come, particularly with use of digital technology and automation. I'm going to invite now, so I'll ask each of all the speakers to give their presentation and then move on to the questions afterwards. If I can have Peter, please, to give his presentation.
Absolutely. You can hear and see me okay? Share my screen. Barry, if you stop, then I'll take over. That should work. Let's see. All right, so pleasure to be here today. My name is Peter Funkhouser. I'm co-founder and CEO at Robotics. So at Robotics, and we saw this quite vividly just before, reality is that companies today are not only hiring people, but they're also hiring robots to get the job done. Now, but today's industry, in many cases, and Shell here was a great example of one of the innovators here, but many industrial operations still rely largely about the physical presence of humans, despite 3 fundamental issues with that. One, certainly there's a large missing workforce. Companies or customers come to us and ask us, we have every day or every year, actually, thousands and hundreds of employees going into retirement. Just in the EU alone, there's 1.5 million plant operators will be missing just in this decade alone. So that's a huge trend of the missing workforce. The second problem is certainly the limited productivity. People are not the right tool to see, to smell gases, to see temperatures. So there's a lot of early indicators in the industry that are missed because we're using humans to perceive and to analyze this data. And that's actually a 270 billion problem every year that could be mitigated. And lastly, fact is, human error is the #1 reason for a lot of the accidents that happen. And that's not only an accident that happens to humans, saving human life, but also the environment and the infrastructure. Luckily, that's what we're discussing here today, there are better ways to do that. So we believe that we're clearly on the verge of the next robotic revolution, where today we can have AI-powered mobile robot into these industries and enable fully autonomous inspection and eventually maintenance, and removing the need to have people at the center, building really an autonomous industry. And we've seen this in the past, where the same happened in automated manufacturing, when robot arms build goods, smart warehousing, where logistics robots roam around the facilities, and it were the same conditions. Workforce shortage, repetitive tasks in a somewhat structured environment. And today on top, we have in the industry that it's even a potentially dangerous environment. So this is really an exciting time all around building together this autonomous industry. Now, the autonomous industry has actually already begun. What we quite often see is that there's a digital twin at the center, a maintenance management system that allows operators to visualize, contextualize, analyze data. And there's 2 streams of information that flow into the digital twin. One is information that flows into the data, providing real-time data to populate the digital twin. And the second part is acting on these insights and enabling, without physical presence, certain actions to be taken on the facility. Now, what exists today is what we call basic automation, where we have connected machinery and IoT sensors that provide the basic level of automation. And we have seen tools such as drones or crawlers helping operators on site get a different perspective without crawling, let's say, into a tank and working at height. So it's really these tools that already exist, but still the physical presence is needed. So what we're doing today with our robots is enable autonomous inspections by having robots with the mobility similar to human to climb stairs and steps, provide data in real time, and then use AI to interpret the data. Of course, then also these robots have the capability to interact through mobile manipulation, turning levers, taking samples, etc. So I'm going to give a quick introduction on how that looks. our product. So this is our robot, four-legged robot called Animal. It's really your friendly robotic coworker that can take over certain tasks. It's fully autonomous, so we guide it once through the environment. It creates a map of the environment, has an understanding, and then we pack it full of sensors up to 15 kilograms, where you have thermal cameras, visual cameras, microphones, gas detection sensors, and really, in a superhuman sense, perceive indicators and anomalies as early indicators of problems. Now, because we use legs, the robot can move throughout the facility, up steps and stairs, without any changes that are needed. And that also includes Wi-Fi, because the robot carries all the compute and autonomy on board, so you can send it down into a basement, collect the data, and then report on it. This is an example. Then if somebody remote or close by gets the remote, gets that actionable insight, and is able to act on it early before actually a bigger problem occurs. Now, we have a lot of robots out in the field with customers in the oil and gas and chemicals industry. What makes these industries special is that you could have potentially explosive gases in the environment, so it requires special certification. Then we're also working in the power, mining, and construction industries, as you can imagine, complex industries that have the same requirement to do continuous inspections of the facilities. And what we could provide our customers is really a better way to collect better data. And that's because you get more insights, it's much faster, it's scalable. As Barry mentioned before, these robots can learn from each other, share data, and it's not bound to one person. And you can do it much more often, because the robots, they don't need to sleep, they charge, but then continue, they can do that 24/7. And of course, because you're using now tools instead of people, you have really a higher increased safety and also accuracy and consistency. So the typical use case with our customers is really about avoiding downtime, unplanned downtime. Quite often you can send in a robot while the operations are still running, whereas if you're human, sometimes you need to turn it off for safety reasons. It's preventing asset damage. And quite often, if you have remote facilities for oil and gas or wind turbines, you're enabling that remote operation. Now, what's exciting is really also the technology behind this. I want to highlight a couple of topics here. So the mobility, what we're doing here is AI-based. So we have thousands of operating hours of the robot walking in simulation, learning how to best use motions and reflexes to conquer these quite complex terrains. And you have to imagine this is not only works in the lab, but also in environments where it's outside, it's raining, can be slippery, so it can be quite challenging. Large-scale autonomy means that the robot can understand its environment through sensors, step cameras, and associate that with geometry. And by that, really move through entire facilities. Then you can also connect that to your digital twin and have a really understanding and enabled autonomy of the robot. Also going around obstacles, so through real-time scanning and mapping. The second part is using the AI to get information out of the data. Here, we're learning models of the environment, and such that the robot can then understand, what do I see here? What's the gauge? What's a good temperature? What gases are okay and which ones are not? And lastly, very importantly, we saw before, integrating that with the ecosystem through APIs. So our team has been working on legged robots for over 10 years now, and it's certainly very exciting to launch the two robots on the right-hand side. These are two robots, Animal and Animal X. The Animal X is a special robot certified for the oil and gas and chemicals industries. But at Anybotics, we're really looking at it as a robotic solution. Also, the software as a full stack is part of it, including autonomous charging, and also then quite exciting, once you have additional sensors you can add on top from third-party vendors, extending the capabilities of the system. I want to conclude with some thoughts on the impact of robotics on the sustainability goals. Certainly one is that renewable energy, sustainable energy can be enhanced through these tools. If you imagine if you have far away facilities, offshore wind, for example, where it's extremely costly to send out people, robotics tools enable them to run them cost efficiently. Obviously, robotics can eliminate a lot of the injuries and accidents that we have seen. And robotics is really a scalable approach for upgrading also existing environment and infrastructures. So the industry is not going to go out and build completely new infrastructure. By having tools that can adapt to the existing infrastructures and environments, we can upgrade them and make them more sustainable. And lastly, by doing more frequent inspection and eventually maintenance, we can also improve the energy efficiency. Barry just talked about it before. Having those small gas leaks detected early on can save on that and help us in increasing productivity and creating less waste. With that, I want to thank you for your attention. I'm looking forward for the questions later.
Thank you very much, Peter. That was truly fascinating. I was thinking, if that presentation was given maybe 20 years ago, it would have been really under science fiction movie. But can I have one of your robots to be my house manager, please? Because that's really fascinating. I'm going to ask Katie to be our next speaker and share her valuable insights with us.
Great. Hi, everyone. Hi. So I'm Katie O'Leary. I'm the Director of Product Marketing at Drone Deploy, and I've worked in the technology industry for the past 13 years, helping companies understand and leverage SaaS technology. So today I wanted to talk about how Drone Deploy is helping the energy industry digitize its assets and push for a safer work environment. So why this matters, right, is there is an estimated $150 billion cost reduction for companies that digitize their assets. And what I mean by digitizing, and Peter and Barry had talked about this, it comes from a few different areas. It comes from transferring data to the cloud to make it more accessible, creating data lakes to organize and improve connectivity globally, and leveraging AI to speed up the time to identify vulnerabilities and take action faster. However, we are visual beings and we require visual context in order to make decisions on what's happening on the ground. This is why even with more data, like using IoT, we still send people into these hazardous environments to understand what the current conditions are, to then ultimately make a decision on what needs to be done. In a basic sense, you can't improve something you cannot see. So the first step in our minds at Drone Deploy is to truly digitize these workflows and create meaningful AI. You need to create a visual representation of your assets and their locations. And for this to be meaningful, the models and maps need to be accurate, measurable, and actionable. So at Drone Deploy, we pull together all geospatial and visual data into our system to support a new way of working. So we're helping teams augment hazardous traditional methods and bring more data to help make decisions safely. Some examples are eliminating inspections that use scaffolding, or being able to capture new data sets like thermal and gas detection data that's not possible to capture just with the human eye. And so for the next couple slides, will go into a little bit more detail on how that works. So we're taking imagery captured from mobile phones, cameras, drones, and robots, and we transform that data into maps, 3D models, and virtual tours to digitize the physical world, creating a complete digital twin. And as Peter talked about, we're excited to work with a lot of different robotics and drone companies where we can truly see a future where there is a drone, there is a robot on every job site, on, near every asset, where you have regularly scheduled data captures to conduct your visual inspections. So having these robots go out there and collect that amount of data will increase your data by 100x and remove the need to have teams conducting those hazardous and remote visual inspections. But as I said before, right, more data isn't necessarily useful unless you have AI and a closed loop system to help you make sense of that data and that information. So Drone Deploy is working towards a future of autonomy where data is captured all the time and where the SMEs are in the office, they are alerted to areas of concern or things outside of normal. They can then make an educated decision on sending out a robot to capture and see assets or see the site in real time before they're sending out a team. So leveraging AI and having access to a large visual data set makes this vision of autonomy possible, where AI is needed at every step of this workflow to make the next accurate and meaningful. I'll talk through in a minute where the workflows exist today and some automated and manual aspects, but working towards a closed loop workflow where the data capture, comprehension, alerts, and the real-time view is all autonomous and all remote, and no one is needed on site to capture this information. Barry talked about a perfect example of the corrosion on a tank, and one drone detecting the corrosion and another drone coming and painting and covering the corrosion. That is a perfect example of what we're trying to accomplish at Drone Deploy. Our customers are finding value in use cases that are expensive and dangerous. They are using reality capture data to improve health and safety, as well as align to environmental and social governance regulations. The renewable energy companies that we work with and the projects that we work on, they need to evaluate and build these energy sites quickly to keep up with growing demand. They also have to get all stakeholders like government agencies, internal teams, and general contractors all on the same page and in agreement on the project and the progress. So we enable these companies to significantly reduce the time to evaluate sites and help to monitor progress to get up and running faster. This is all while reducing people from traveling and being on site and creating a single source of truth of what the current site conditions are. Vegetation management is a time-consuming and tricky workflow for our energy companies, trying to catch issues early if there's a leak, but also to help with fire prevention and loss of electricity. So using just the basic RGB sensors on drones, with Drone Deploy, we're able to identify plant health, elevation, and location. And this provides critical information at scale to our customers on what type of plants they are, if they're healthy or not, and a quantitative density assessment of growth on site. Many companies are still using helicopter patrols, which are the single largest item on a budget and are a major safety concern. Reality capture data with AI helps to streamline operations and move from a cyclical to a condition-based approach to maintaining assets. And as a bonus, you can share this visual data and compliance documentation with regulators. Typically, reclamation and planning workflows are done with third-party surveillance and consulting firms, taking a lot of time, and it's quite costly. Regularly capturing reality, our customers are able to share maps with anyone on the project. They can compare against design, see elevation, check stockpiles, which are all automated workflows through our system. And again, this is eliminating the need to have more people on site, speeds up the reclamation process, and as I said before, creates that visual documentation for the company, making it easy to share out with stakeholders and regulators. And as with other large assets, the traditional methods of inspecting and analyzing data are very expensive, using scaffolding and helicopters, and they're inherently dangerous practices. With reality capture data, our customers can better understand the landscape to conduct inspections on tanks and containment berms. This new process mitigates risk against potential leaks and spills and removes the need for manual measurement. I wanted to end with a video of what this new future of robotic inspections can look like. Assets need to be inspected and monitored regularly to avoid leaks or environmental damage. This work can be hazardous for employees and very time-consuming. With Drone Deploy platform, robots can be sent on autonomous missions to gather real-time and accurate data, saving costs and improving worker safety. The operator is safely in the office, conducting a visual inspection remotely or comprehending alerts to then take action. this is all I have, and I appreciate everyone's time. If you're interested to learn more about use cases for reality capture, data and AI and energy, you can scan the QR code to see a detailed video of drone deploy. So thank you.
Thank you very much, Katie. I guess with the figure that you gave, which is $150 billion yearly, I mean, everyone should be interested in the adoption of this technology. It's amazing. I mean, we really underestimate how much cost saving and improvements in efficiency, along all the other things that we have heard from you and the co-speakers, we can get from development and technology. I have lots of questions, but I'm going to invite now Ivan to join us and give his presentation.
Thank you very much. I'm going to share my screen. Can you see my screen?
Yes, we can.
Okay, thank you very much. So my name is Ivan Petillot. I'm a professor of robotics at Harvard University. And we've just completed the large-scale project in the UK around called ORCA, around how can we use robotics to demand and de-risk the offshore energy of the future. So, and that involved robots at sea, robots flying, and robots on platforms like the animal robot, which we have used extensively in collaboration with the University of Oxford. So today I've been asked to look at the marine aspects of this inspection. And that's what I'm going to present over the next 10 minutes. So if you look at offshore wind energy, it's seen as a key element of the net zero transition. And 30% of the cost of that will be in inspection, repair, and maintenance. Now, this is a small wind farm. We have to imagine that in the future, we're going to have wind farms with thousands of wind turbines, and we're going to have thousands of such wind farms. So we really need to find a way to scale the way we do inspection, repair, and maintenance. I don't know why my slides won't work. So we're going to have, larger wind farms, more turbines, and we're going to have them everywhere. So we're really interested in seeing how robotics can help change the way we do things. But more importantly, in that case, I think if we don't adopt robotics, I don't think we're going to have a sustainable model to use those wind farms in the future. So if you look at how it's done now, it's done with a mixture of people hanging off ropes, big ships being sent to deploy underwater vehicles, and people on platforms. This is a nice day, but you have to imagine that it's not the case all the time. Actually, the operational window when we can use humans offshore is actually quite small. And so there's also an element of, can we develop technology that can be used more often, more cheaply, and more scalable? So what we're looking at here is to replace large ships with a crewed system, a crewed element, by autonomous systems, typically an underwater vehicle, which will do the inspection of the subsea, a surface vehicle that will help for deployment and persistence, and aerial vehicles. And like every speaker, I'm a great believer that it's not just about the robot, it's about the data that you capture with the robot. And there's two things about that data, is you can process it with AI, so you can autonomously detect defects, cracks, corrosion, etc. But you can also give the data access to third-party users who don't have them to be on site. And therefore, you can effectively expose the data to a number of specialists wherever they are in the world. A third element of this equation, I think, which is quite important, is you're also opening this market to people who currently are not able to use this in terms of jobs. So if you think about it, if you have to be going offshore, people who are disabled or people who have a family, it's much more difficult. With this type of technologies, they can work from their home, certainly remote from shore, and really have an impact in the world. So I'm going to show you what we've done on our project. It's a small element of the solution, but it's getting somewhere there. So what we've done here is we've developed an autonomous payload. And this is effectively a stereo camera with a lot of embedded intelligence. So we've got some processing power in there, and we're linking that to other sensors on the platform. And that payload can be deployed on any vehicle and make it intelligent. Because all of the problems we have is we need this to be sufficiently autonomous that when you're remotely operating it, you're going to have delay in transmissions, you're going to have potentially issues with the communications. The vehicles have to be inherently safe on their own while they're deployed. So with this, we can put that on a number of platforms. And this is an example of us doing an inspection of a wind farm. So you have to, on the left-hand side, you've got the video being captured by the robot. On the right-hand side, you've got what the remote operator would see. So we don't have the bandwidth to send all the data. So what we send is a 3D model, a crude 3D model, actually, of the wind turbine. And that's enabled the user to see what's going on and to understand where the vehicle is with respect to the platform, whether it's safe, whether it's capturing the right data. And this is we found this very useful because the human operator is in the loop. So also this is done fully autonomously. At any point, the user can say, actually, I don't want you to do that. I want you to stop doing this and go somewhere else. But if you lose communications, you're safe that you know the vehicle will be safe and will avoid obstacles and will not collide with the structure. So that type of approach, I think, is critical because you need to think about the user as well as the autonomous system when you develop those solutions. Because if the user doesn't trust them, they won't use them. And if they won't use them, no matter how good your technology is, it's not going to make an impact in the real world. So with that, so one of the things is we've done this for real. So this is offshore in a wind farm in the UK. And this is the type of data we can get. So the vehicle is autonomously inspecting quite a large foundation and in real time generating a 3D model that you can see here. That model is then fed into the system so we can use it to navigate the vehicle. And that's all online. And you have some loop closure for those of you who are interested. So we can really get good navigation. Away from home, so after the mission, we can generate much better quality reconstruction. And that's where all the AI comes in. This data can then be fed into an AI system, and the AI system can detect cracks, corrosion, etc. So I've got two examples of that coming next. So the first example is us detecting anodes and fill joint on a pipeline. So the vehicle is autonomously driving around, and then you can detect the corrosion. And you can then build a 3D model that you can expect in virtual reality. The second example is for pipeline following using deep learning, where we can do this. And that's all embedded on these small platforms that I've showed you. So you can move it around from platform to platform and get the autonomy inside. So this is not just science fiction. Next year, we have a program of work currently working with a company called Fugro, who are lead in geospatial intelligence, where our technology is going to be deployed on their ROV, which are at the bottom, which is linked to a 12-meter surface vehicle, which is already operational. So next year, we're going to do this inspection autonomously from shore using a surface vehicle and an underwater vehicle. Now, I wanted to finish to kind of put everything a little bit in perspective, however, is if you think about most of the use cases and the business cases for this, if you're going to deploy those robots on an offshore platform or underwater, they need to be reliable. So if they're not reliable and they break, you need to send someone to recover them. And that breaks your business plan completely. And at the moment, I don't think we're there yet in terms of reliability and persistence. So there is quite a lot of work to do still to see those vehicles becoming mainstream, because for that, they need to get to a level of intelligence and reliability that we quite don't have at the moment. The second thing is we're very good at inspection, and we've seen lots of great examples today. As soon as we want to manipulate, we are much more limited. And I think that's, again, an area where we really need to work as a community to develop the manipulation. Because if we can't manipulate, we can only diagnose a problem. We still need to send someone or something to fix the problem. And so this presents a lot of challenges, but I think we don't have a choice. Certainly in the energy sector, with the challenges we have and the scale of the work we're going to have to do, I think we need to push for more robotics, more AI, and that within the next 10 years, I think we can have a significant impact on the way things are done in this very difficult environment. Thank you. That's me done. So I'm going to stop sharing.
Thank you very much. You said something very interesting about the data sharing and data being accessible from anywhere, wherever you are. And this made me think about a concept that has been actually very cleverly and nicely evidently put about artificial intelligence, automation, robotics, the democratization of data and decision making. So that is one development we should welcome. I'm going to move on now to the Q&A, but allow me, I'm going to target my first question to you, Ivan, only because you refer to this issue of data, but my question goes also to all the speakers if they want to comment on that. Because in every single presentation, the word safety has been highlighted as a main benefit from the use of robotics and AI, digital technologies. But what came to my mind, and again, forgive my ignorance on the technical side, is cybersecurity, cyber threat. Because there was an interesting survey whereby they showed how energy companies are going big on the adoption of these technologies, but very few have thought thoroughly about cyber threat and cyber security. And that is something that more and more we're going to hear about, because so far attacks are happening, but I don't think this kind of data and experiences are being shared. So I would love to get your view, Ivan, on this issue, to what extent you see, because you mentioned some technical challenges, but I also want to ask you about this challenge, the cybersecurity challenge, and if other speakers would like to add to that, please go ahead afterwards.
Yeah, absolutely. Cybersecurity will be a big problem. But I think we have, that's a problem that's going to become even more crucial when we have systems that are deployed routinely, which is not the case at the moment. We're really doing pilots, developing the technology, proving the technology. We shouldn't forget about cyber, because as soon as the technology will be proven on the technical level, there'll be a certification aspect. And cybersecurity will be, I think, core to the certification of those systems. So yes, it's a big problem. We're aware of it, and there are people working on it. It's not just about an afterthought either. So you can't just say, I'm going to develop a solution and then I'll solve the cyber later. There are some core fundamental problems in the way you communicate with those robots, where at the core of them, you need to embed cyber, and people are starting to work on it. But it's just starting, I would say.
Peter?
Maybe I can expand on that. Yes, fully agree. That's very, top of mind for us, and that's an area where we're heavily investing in, right? Every robot that you introduce, you're introducing a new threat vector, right? That could become a problem. And similar to the safety certification, where it's about you're not allowed to cause a problem, right? You're not allowed to cause an explosion. That's a very high standard you need to fulfill. The same levels or even beyond applies to cybersecurity. Now luckily there are solutions, but you have to engineer from the beginning into the system. Think about it when you create your architectures. So it's typically when you watch YouTube videos of robots, you wouldn't think of that, right? But it is a necessity and a requirement if you're deploying in industrial environments.
Barry, let me move on. I'll actually follow up on this question, ask you, I mean, this has been a challenge, cybersecurity, but if we look at it more broadly, what would make robotics success or failure in the energy industry. I mean, so far I find it difficult to see them as a failure based on what you said, and you were all convincing. But it would be great to hear your perspective on where do you see them really either making it or breaking it in the industry, energy industry.
Yeah, I think it's related to the previous questions as well. Yeah, there needs to be a few things absolutely sort of fundamentally built in: cybersecurity, the whole safety behaviors of robots, predictability, actually say it. In some cases, it's like, I don't care in this phase whether a robot fails or not, but it needs to fail predictably. So in some cases we say, I don't want it to find its own way around an obstacle yet. Just stop and let us be part of the decision process. So predictability is very important for us. I think for the bigger scale success, we need to have volume. So that's where an entire industry and far beyond that needs to start thinking about how we can scale up. It's not just us playing in sandboxes. This is the scale up. It's maybe in the space like drones, the regulations around the planet vary so much that we can do magical things in one country and completely nothing in the other country yet. So that will come. It will have its own pace. And that also comes with sort of the whole supply chain, who does what, when, where. And I think that's why typically these kind of things is we're all in it together. We're not just one company that has one robot and loves to play with it. No, we want to have a diversity of robots for all kinds of functions. And there's a whole supply chain and a service chain and everything behind it. So it's a far bigger picture than just a bunch of cool guys developing a cool tool. No, absolutely not. This is a game changer, and that needs all of us on board.
Absolutely. I mean, actually, what you mentioned, and that's another thing that I kept on thinking about, is the issue of regulations, because typically technology moves much faster than regulations, and usually regulations, they play a catch-up role. And we have to be careful that the industry is global, and actually you don't have the same level of sophistication with regulations. And there is a huge variation between one country and the other. And if I understood you all right, that cooperation would be very important. Katie, let me turn to you and ask you about the next frontiers in terms of robotics for the energy industry in particular. Where do you see that?
Yeah, I think everyone touched on some of those frontiers, right? It's having the ability to, and right, Barry talked about this, we still need to get to scale. There still needs to be a point where these aren't just POCs, but everyone has a drone in a box on every job site. There's a robot on every job site. So we still have some time to get there, but it's being able to be alerted and understand that there's something outside of normal on your site with your asset, and then being able to take action remotely without having to send a person. And so, right, Yvonne, talking about offshore and having the connectivity between your robotics that are underground, that are flying in the air, and having a solution that has something that can connect all of those different robots and make sense of it and take action. So that's where it is exciting, and where Drone Deploy is moving towards, is being able to connect those different systems and help make sense of them. Once we get to the scale, as Barry said, drones took time to regulation to catch up. There's still some regulations that need to, right, you need to get special waivers, and it depends on what country you're in. Robotics needs to catch up to that as well, where there's the cost goes down. It's accessible for smaller companies to have a robot on every job site, for every asset. So we're getting there, and it's exciting because looking at drones, you can see that robotics are following that same trajectory as drones did. And so we'll get there. And I think it'll happen faster because of the experiences governments and companies have had with drones. I don't think it will take as long as it has been with drones, and the technology is moving faster. So it's an exciting time.
I'd like to add a little bit to that. I think the robot as a service is important. So at the moment, we're developing technologies. At some point, we're going to have to have a new service industry around those robots, where the user of robotics, they don't care about robots. What they want is the data or the facilities, the capabilities of the robot. And they'll delegate that to a company to say, I'll service the robot, I'll maintain it, I'll develop it, you just basically rent the service like you would do with any other service in industry, and that will come, I think, and that will come fast as soon as we have the level of understanding and reliability that we need to exhibit in the robots. But that's the next step, really. We're at the step where we're proving the technology. As soon as that's done, we're going to move to the serialization of robotics.
Thank you. Peter, I want to turn to you because actually I have two questions for you, but let me start with the point that Katie made about the smaller companies. But if I got it right, I mean, you have a first-hand experience on the role of smaller companies and the diffusion of this technology. So how do we bridge between these two? Because of course there is a capital requirement, there is technical capabilities, but I mean, I'm not underestimating what the startups and smaller companies can do. Actually, they drove the share revolution in the US, but in this area, it seems to be like, is it too much for the smaller companies to chew, or that's really a niche where they can really capitalize on?
Yeah, it's a great question. And certainly the complexity thereof we feel every day, right? We're building such a complex product that consists of hardware with the complicated supply chain, certifications, and the vast amount of software that we need to write. What we were very lucky in is certainly that we had that vast experience and time that we're able to do things at the university. Right, that's a fundamental place where you can build up the basic technologies, build up the team, the know-how, the expertise. There's only worldwide a few companies, including some in the US, some in China, that had the luck to have decades of experience, such that we can productize these technologies today. We see other companies trying on the same level, but the entry barriers through the complexity is extremely high. So what needs to happen is also an ecosystem needs to build up, right? Robotic ecosystems of tools, that's starting, but it's still very limited, immature. So once we really have, I think there's going to be a pull effect. Once we really have thousands of robots out, people will see the opportunity and the ecosystem will grow, enabling also smaller companies, again, provide their niche value into that. But right now, certainly, luckily, we are in that position, and some others as well. But we shouldn't underestimate the complexity of it, definitely.
And let me just follow up on the second question I had with you based on the presentation, because again, it's something that I think most of you, if not all of you, refer to in your presentations, is how robots will replace people in performing certain tasks, especially riskier tasks. But and you mentioned in your presentation, Peter, that the industry is already struggling in kind of replacing its workforce, the aging workforce, and not many young people are interested in joining the industry. But in this case, with the development of robotics, aren't you also sending more message to the potentially future workforce, the people who go to universities and who would want to join the industry? Will they feel threatened that at some point there won't be a job for them in the industry because it has been taken over by intelligent robots?
I think.
Let me start with Peter, and then I go to you, Ivan, because I was going to come to you next, just because he mentioned that quite clearly in his presentation first. Please go ahead, Peter.
What we're observing right now, it's quite the opposite, right? A lot of companies actually want to work with us because it also sends signals. Hey, we're one of the innovators. You'll get to work with robots. So that's a signal effect. We have so many school classes and the people that literally start want to study mechanical engineering, electrical engineering, because they can contribute that. So I think right now it's a very positive signal towards the young people that orient themselves to enter the workforce. Now, for the people that are at the companies, certainly there's an important way on how to communicate. What do these robotic tools do? What do they don't do? How will that impact your work in the future? And so here we're collaborating closely with the companies to help them also in the communications, in the change management. We're still early in that. We don't have thousands of robots out yet, but it's a very crucial aspect to get that right. Otherwise, people will not like the robots, right? They're going to sabotage and not use them. It's an important transition that a lot of decisions have to be taken right.
Ivan, please go ahead.
Yeah, and I mean, I'll give you an example. The surface vehicle work with Sugar, the red vehicle in my presentation, that requires a team of 6 people onshore. to operate. Now, it's not replacing a big ship, but for the same price, you could have 10 of those rather than one ship. And so you have more people actually working remotely than you would have offshore. So, and you're really opening the access. The industry is struggling to recruit the right caliber people and the right people to work offshore. It's very difficult. You're now widening the access to lots of different people who could actually make a difference. So I don't think it's gonna be the problem. Plus, you're creating this new service industry to maintain and look after the robots.
Yeah, I'll elaborate a little bit more on this question with Barry. And I tell you here, what I have in mind is particularly the developing countries, where for them local content, creating local job opportunities is very important. You can see in their legislation, when companies sign a contract with those governments, you can see there is a provision that clearly talks about having X% of the services and the people provided or job filled by locals. And I remember before COVID hit, and I was traveling to some African nations, that was a concern that people were worried about, that what does that mean for local job opportunities and for local service industry, not in the rich world, where everything is pretty well developed and we have all the sophistication, but primarily in the less endowed governments in terms of, like economic growth, service industry, money, etc. So Barry, I really would love to hear your views on that, how you're bridging between those aspects.
And it's definitely a topic that we do not shy away from. It's like mentioned, there's a lot of trends that say, yeah, we get more jobs, and other trends say we have less jobs. What we say is, well, definitely the jobs will change. There's no illusion about it, because we're fighting multiple, maybe conflicting drivers. We want to be safer, more sort of emission detection, those kind of things. And yes, we want to take people out of harm's way. One word of caution: we still believe we're not putting people in dangers, even though that's claimed by other speakers. No, we want to make sure that before a job starts, everything is safe enough for a person to execute a job. But by going robotics, we can make it even safer. So that's a driver we definitely want to pursue. Does it mean that everyone's out of a job? No, jobs will change, but they go in small steps. The person that I started my pitch with was walking around with his hands in his pockets doing surveillance. That same person can do the job far more efficient by not doing the walk around, but more focus on the things that a person is really good at, is intervention, is understanding complex problems, those kind of things. So jobs will change, even maybe especially in countries with a lot of sort of labor content. There's also a driver for upskilling. So we have locations where I remember one of our supervisors pulling his team together and saying, guys, you may consider this robot as a threat, but I can tell you the person that doesn't embrace this will be out of a job soon, because this change will happen. You may be able to slow it down even, but if you embrace this and learn to work with the robot, you'll have the great job in the future. So there's some passion around sort of this upskilling as well. So let's not make it a full negative one, but it's definitely a subject that we need to sort of keep pushing for local content in service industries, in whatever comes next with it, because there's a few things we just don't know yet that will still come our way. So yeah, I'm not that negative about it.
So in this respect, actually, what you're trying to say is that even if one door appears to be closing, a much bigger door will appear along the way for the industry. I of course I can go on and ask you so many questions, but let me start taking the questions from participants. We still have around 10 minutes for that. And I can direct the question, but feel free to jump in. Perhaps, Katie, I can ask you the question. The first question we have: please describe the most important human-computer interaction problem for interacting with robots.
Sorry, the most complicated part of it?
The most important human-computer interaction problem for interacting with robots.
Not sure I quite understand, but I think, right, we talked about a lot of being able to have access to current conditions and what's happening at that moment in real time. And so being able to have a robot or have a drone that can live stream or bring back that data and information so that you can make decisions, you need to have software, you need to have a location or somewhere where you can teleoperate, where you can comprehend that information. Whether you're on the outskirts, right? We have companies that instead of sending 10 people to do a visual inspection, they'll send one person to fly the drone, capture the information, live stream it, send it back to the team, and you can make decisions together, remotely and on site. But having that layer and information, right? You need some software solution to help comprehend and make that decision.
Maybe I can add on that, complementary. Thank you, Katie. It's, when you interact with a robot, it's a vastly complicated machine. So simplicity is one of the difficulties. How do you boil that down, right? And what you do is imagine a robot that walks, right? The person doesn't command the leg. So you're adding a lot of autonomy. So you want to click somewhere, the robot walks there. So it has to have a natural feeling. So you're baking in a lot of autonomy. The danger of that is people don't understand what is the robot doing. So transparency puts you back. So what's the intended purpose? Can I look ahead into the future, what the robot's going to do, previews, things like that. There's a lot of unsolved problem, quite an exciting also research field of human-robot interaction through software.
Thank you. I'll move on to the second question. And again, even if I directed one person, but you don't feel comfortable answering, I'll direct somebody else. The second question is, how do you imagine the timeline for construction and usage of AI algorithm for failure detections for O&M? Who would like to take that?
Okay, I can.
Yeah, actually, I had you in mind, but I'm glad you stepped in.
I'll have a go at that one. So I think a lot of the machine learning algorithms need a lot of data. We have a lot of data actually in the industry. The problem is that data is not necessarily accessible. So digitization will help that. So when we start digitizing the asset, we'll get all this data in a form that can be used. We're actually working on a project at the moment with some oil and gas industry, where they're looking at that. They're looking at which architecture do we need so that we can extract the data from the offshore assets with robots, put it into a platform where we can then develop AI. And the model they have in mind is they won't be developing the AI themselves. What they want is people who know how to do machine learning to get access to that data and be able to develop an app. So you then buy an app for corrosion monitoring from a supplier, you buy another app for another person for something else, for aging. And the more data you have, then you can start building models. So I think initially you will just do analysis, then you will start to do prediction. And eventually, as you link that to digital twins, we've talked a little bit of digital twins today, which are models of a system running and being able to synchronize the model with real data. Then you can start to do what ifs and predictions in the future. So that's, I think, the timeline. And in terms of, if I had to put a time on it, we could do the analysis today if we had the data. It's going to take 3 to 5 years, I think, to get to the digital twin model and the prediction. But in the next 5 to 10 years, we should get there.
Thank you, Ivan. Let me take one more question from the participants, and then I think we'll have a few minutes to wrap up. How important is audio analysis when conducting remote monitoring? So we have seen how robots can detect gases, thermal signatures, interpret visuals in their surroundings. Audio can also be an interesting vector to detect anomalies. Who would like to take that?
I can start and then hand over to Barry or to Katie. We have a microphone on the robot for exactly that reason, right? So any rotating equipment, anything that moves will vibrate and hence have some sound with it. And humans are quite good at listening to something, saying, hey, something sounds fishy, right? But we can do that much better with a robot, from a full spectrum audible sound to ultrasonic sound. So it's a great signal for early indications of problems.
Anyone else would like to add to that?
I think it's one of those key pieces, right? It's like sight, sound, right? There's a few different things that need to happen for you truly be able to remove a human in that environment, because exactly as Peter said, we have customers that say, that's great, I have this virtual tour, I can walk my facility, I can walk my assets, I can see exactly what's happening. But exactly what Peter said, if you can just hear it or see the gas sensors and all of that is connected together, then you really truly understand if things are good or not good, and you need to investigate further. And so being able to have all of those senses come through in a digital way where you can comprehend if things are safe or not, that will make it where you truly can remove a person from a hazardous environment, or just a not necessary, right, until it is necessary to have someone on site to fix something. But if you can have the robots understanding every asset, every facility all at once, and then you're only sending people in environments where it's necessary. So yeah, that'll be the next step to connecting all of that.
And actually, I was going to, because we don't have time for more questions from the participants. And thank you very much for those interesting questions that you sent us. But I would like to wrap up this session by asking each of the speakers very briefly to tell us how do they see the future of the energy industry with the use of robotics in the next 10 years. And the reason why I'm interested in this is because we hear that there's still a lot of uncertainty, a lot that we don't know. But also if we look at the industry 10, 15, 20 years ago, it was pretty different from what we have today. Technology is moving quite fast. So I know I'll ask you to gaze into your crystal ball, but also from your experience, and you have hands-on experience with how fast technology develops. How do you see, if you were to describe the industry in few sentences in the next 10 years, what role for robotics and digitalization, artificial intelligence you will see there? How is it going to shape the global energy industry? And I'm going to start with the person first on my screen, that is Ivan, please, and then I move on to Peter, Katie, and I conclude with you, Barry.
Okay, thanks. So to me, I think is the key is to take baby steps. It would be a mistake to say we're going to do autonomous inspection tomorrow, fully autonomous, because it's not going to work. We're not ready for that. So what we need to do, I think, is have connectivity is going to be key. So if you have a connected robot, you can then introduce intelligence and autonomy and AI when it's ready, run it in parallel with human for a while, and when it's adopted, you move on to the next step. So you basically have a timeline where over the next 10 years, you start from full teleoperation of the robot, very dumb, to a robot that can be very, very capable. And you learn on the way through the data and the experience that you've gathered to make those vehicles more capable and more safe. And I think that's the way it's gonna happen. And I can see that if we do that reasonably quickly, we're gonna transform the industry.
Thank you, Evan. Peter?
Yes, I can fully agree with that, Ivan. So we're really headed to what I believe is this autonomous industry, and the robotics is going to be one of the key enablers, not the only one of the key enablers. I'm sure in 5 years, it's going to be quite normal. As we know in manufacturing today, you have robots. Things we touch have been built by robots. Things we get in the parcel, right, from the post, has been handled probably by a robot. That's going to be just an everyday case. And I think it's often, when you look back 5 years, we have done tremendous progress, yes, but it's risky just to project that linearly. Things happen exponentially. So once momentum is set, I think things are going to happen quite fast.
Thank you. Katie?
Yeah, I agree that there are kind of baby steps to get us to that closed loop process. We talked about a lot of what that vision is, but I talked about it quickly in my section of being able to really create that digital twin and see that $150 billion right cost reduction. There is we're creating sort of a data management, I don't want to say nightmare, but we're creating a lot of data. And so companies are also needing to understand how to house and comprehend that data and information. So right, first step is gathering all of the digitizing your assets, right? Creating those digital twins, whether through drones and robots and cameras and pulling all of that information together. And for our companies now, they're trying to figure out how to, as you said, Carol, try to democratize the data. So how do we bring it into a data lake, bring it into an AI system so that it's useful and meaningful and people have access to it. So we're in this phase right now where it's easy to digitize your assets and gather information, and we'll get even more autonomous and faster and create more data. But then, right, how do you house and comprehend that data is kind of where we're in right now. And once we figure out that, right, making them repeatable and reliable, as Yvonne said, and then it will truly have that closed loop process.
And Barry, I give you the last word.
Thank you. Yeah, of course, agreeing with all of the above. But my pitch is more about it's a people game. It's not about robots. It's not even about data. It's about us understanding as companies how to do with it. So within Shell, we really have a capability building focus. If we learn how to deal with robots in all kinds of work processes, so it's not just operational surveillance, it's also the construction phase. It's also about maintenance, it's also even demolition. Maybe we have such an advanced process soon with robotics that we can have life cycles far shorter and far more so cyclical than the 30-year lifetime that we're designing for right now. So all of those learnings of today hopefully will be adopted in our assets of the future, whatever they look like. So that's my expectation. It's, of course, there's a hardware development, there's software development, there's all kinds of AI and digital twin kind of developments happening in parallel. They're not waiting for us. It's happening. We have to sort of embrace this, adopt it, and really learn to develop our capabilities with it. So we are accelerating that energy transition with it. So my big hope and expectation is that everything we do is about learning and making it as ready as possible, as soon as possible, for all our future facilities.
Thank you so much. And actually listening to all of you guys, your valuable insights and impressive experience, it makes me even more convinced that there is definitely a place for the oil and gas industry in the energy transition, and that will be supported by all these advances in technologies. I could go on and on asking all sorts of questions, but sadly we reached the end of our session. I learned a lot from it, and I hope you participants have also enjoyed it as much as I did. And I want to thank each one of our speakers, Ivan, Peter, Katie, and Barry, for your tremendously valuable insights. And I think I need to hand it over to Guillaume to guide us what's going to happen next. And thank you very much for having me with you.
Thank you very much. Yeah, thanks. Thank you very much, Carol, and big thanks to Peter, Katie, Ivan, and Barry, as well as to all the participants for making it such an interesting discussion. We had lots of great questions and amazing insight into how robots are transforming the energy industry for good. And now we encourage you to check out the AI for Good program online to see more robotic sessions that may be of interest to you. For example, on Thursday, the 30th June, we'll have a session on autonomous robots transforming the future of construction. And we are also delighted to announce that the ITU will participate at the European Robotics Forum 2022 from the 27th to the 30th June in Rotterdam, the Netherlands. And we are very much looking forward to engaging with you in our upcoming events. And this is the end of this section and the start of the networking in the AI for Good neural network with the panelists and participants for the next 10 minutes. So see you all in a couple of minutes. And now I give the floor back to Anna for the closing information. Thanks a lot.
Thank you for participating in today's AI for Good session. We hope you've learned something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the satisfaction survey, connect with interesting profiles, or speak one-on-one using the chat and video function. After the 30-minute networking session, we invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits and poster boards, and build your personalized AI for Good program. It was a pleasure learning with you today. See you at the next AI for Good.